Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. In this video, we discuss the solutions of 4 problems from the section Matrices and Determinants. And this is the part 4 out of the 5 parts of the video devoted for matrices and determinants. Right. This is the question that has appeared in the JEE Main exam held on 24th January 2025 in the second shift. The given question is, if the system of equations, this is the 3 equations in 3 unknowns, involving 2 unknowns, lambda and mu. Let's call this a system as the system 1. This system has infinitely many solutions. Then find the value of m minus 2 lambda. We are given 4 options. Let's now discuss the solution of the problem in detail. We have the system 1 and it has infinitely many solutions. If delta is equal to delta 1 is equal to delta 2 is equal to delta 3 is equal to 0, delta 1, etc. stand in the usual sense, where delta is the coefficient of the coefficient matrix of the system. The coefficient matrix is the delta is the determinant of the coefficient matrix. Right. So what's that? Determinant of 2 minus 1, 1, first row, 5, 1, 3, 5, lambda 3, second row, 100 minus 47, mu, the third row. And delta 1 is same as the determinant delta with the first column 2, 5, 100 is replaced by the values 4, 12, 212. Likewise, delta 2, delta 3. Right. Let's first of all take, you see, the question is to find the values of mu minus 2 lambda. So, look at them, delta 1, delta 2, delta 3. And if I take delta 1, you will get lambda mu term also, lambda mu will be there. So also in delta 1. But if I take delta 2, if I evaluate, we will get mu in terms of mu. If I take delta 3, we get in terms of lambda. Therefore, first we attack delta 2. So take into delta 2 is equal to 0. Now, here what is that I have done? I have made these 2 entries 0. How? I made R2 is 2 times R1 minus 5 times 2 times R2 minus 5 times R1, and thereby this becomes 0. R3 is R3 minus 50 R1, R3 minus 50 times R1, thereby this becomes 0. Right. Now expand the determinant by its first column. Then it will be 4 times mu minus 50, 4 times mu minus 50 minus 12 is equal to 0. Evaluate, you will get mu is equal to 53. Right. Delta 3 also we take, and it involves lambda. And what we have done is, we have done elementary row transformation, that is R2 is 2 times R1, 2 times R2 minus 5 times R1 like the above, it becomes 0. R3 is R3 minus 50 times R1, this becomes 0. Now expand by first column, we will get this, and simplify, we will get lambda is equal to minus 2. So thus we got lambda value, mu value, so mu minus 2 lambda you can obtain very easily, and the answer is over, right. But you see, now take delta, and wherever there is lambda you write minus 2, wherever there is mu you write 53, and evaluate for yourself, for your convincement. This is 0, you can check, and take delta 1, lambda value, mu value substitute here, and expand this, you will find it is 0. Please check. These two things I am leaving it to you. It's only for your satisfaction I am doing this, right. Now, having got the values of mu and lambda, I want mu minus 2 lambda, and that will be 57. Where is my 57? Option 4. The answer to this question is option 4, right. That is the detailed discussion of the solution of this problem. In this, what I have shown you is that you can save some time by doing this. First consider delta 2, then delta 3, then get the answer. And if the answer is present, you are done. This is a delta and a delta 1 for those values of lambda and mu. You can check for yourself for your satisfaction. Right. So that is the time saving trick that you can think of. Let's move to the next question. Right. This question has appeared in the JEE Main exam held on 23rd January 2025 in the second shift. The given question is the system of equations. Again, the system is here. Call this system as 1, which involves lambda and mu, has no solution. So this system has no solution if for what values of lambda and mu, various values are given here, and for which combination of lambda and mu, and this system has no solution. Right. Recall the system 1 of equations has no solution if delta is equal to 0. The determinant of the coefficient matrix is 0, and at least one of delta 1, delta 2, delta 3 is non-zero. So take delta. In this coefficient matrix, the determinant of the coefficient matrix 1, 1, 1, 1, 2, 5, 1, 5 lambda. Delta 1 is same as delta with the first column replaced by the values 6, 9, mu. Likewise delta 2, delta 3. Now first condition, delta is equal to 0. Now delta, what is the value of delta? Delta we have taken and done the elementary row operations. R2 is R2 minus R1, R3 is R3 minus R1, and thereby the first column becomes 1, 0, 0. So expand the determinant by its first column, then and simplify, you will get lambda minus 17. And now delta is equal to 0 will imply lambda is equal to 70. Agreed. Now to evaluate the determinant, you can also work out without doing this elementary row operations. So straight away you can do it, and still you will get this one. Now take delta 3. The convenient one is delta 3. Why? Delta 1 involves lambda and mu. Delta 2 involves lambda and mu again. So delta 3 involves only mu. So take the delta 3, which involves mu alone. Now make an elementary transformation. R2 is R2 minus R1, R3 is R3 minus R1. You will get first column 1, 0, 0. Expand by the first column. Expand the determinant by first column. You will get mu minus 18. and delta is equal to 0, at least one of these delta 1, delta 2, delta 3 is non-zero. So let this delta 3 that is not equal to 0, that is mu minus 18 not equal to 0, that is mu not equal to 18. So if lambda is equal to 17 and mu not equal to 18, if you take, then the system has no solution. So the system has no solution if lambda is equal to 17 and mu not equal to 18. Where is the combination of the answers? So that is appears against answer option 4. That is the detailed discussion of the solution of this problem. Right. We move to the next question. This question has appeared in the JEE Main exam held on 23rd January 2025 in the second shift. Let A is equal to Aij be a 3 by 3 matrix such that A multiplied the column vector 0, 1, 0 is equal to the column vector 0, 0, 1, comma, A multiplied by the column vector 4, 1, 3 is equal to the column vector 0, 1, 0, and A multiplied by the column vector 2, 1, 2 is equal to the column vector 1, 0, 0. Then you have to find A, 2, 3. The entry in the second row and third column is equal to. We are given 4 options. Let's now discuss the solution of the problem in detail. Let A be this matrix. A11, A12, A13, etc. Right. Take the first one. Now first, A into the column vector 0, 1, 0 multiplied by the column vector 0, 0, 1. The matrix A you write, and A23 I have written in red because I want that, multiplied by the column vector 0, 1, 0 is equal to 0, 0, 1. When you multiply any matrix, post multiply by a column vector 0, 1, 0, the answer will be the second column. So the second column is equal to 0, 0, 1. That will give you A12 is 0, A22 is 0, A32 is equal to 1. Right. Now, put this A12 0, A22 0, A32 1. Don't keep them as it is. It will be very clumsy. And so, take A into column vector 4, 1, 3 is equal to 0, 1, 0 is equal to, the matrix A is written as A12, A22 0, A32 is 1. Right, multiply. If you multiply, you will get this one is equal to 0, 1, 0. So in this, you get 3 equations. What equations are required, I do not know. But this is the second one. 4A21 plus 3A23 is equal to 1. Right. Take the third. A into 212 is equal to 100. A into 212 into 100. So multiply and put it here. Put it here. And this entry is 2A21 plus 2A23 is equal to 0. This is 0. And here 4A21 plus 3A23 is equal to 1. Here it is 2A21 plus 2A23 is equal to 0. Solve. Then you will get A23 is equal to minus 1. Right. A23 is minus 1. Where is the answer? The answer appears again as option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem. And by putting A12, A22 is equal to 0, A32 is equal to 1, you will be saving some time. Right. Right. This question has appeared in JEE Main exam held on 23rd January 2025 in the first shift. The given question is, if the system of equations, this is the system involving lambda, lambda minus 1, lambda minus 4 and so on and so forth. And let's call this as a system of equations 1. And it is given it has infinitely many solutions. Then required to find the value of lambda square plus lambda. And we are given 4 options. Right. That given system has infinitely many solutions if delta is equal to delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. Now, you economize the time like what I say. Take the delta is the coefficient matrix. Lambda minus 1, lambda minus 4, lambda coefficient, the determinant of the coefficient matrix. Lambda, lambda minus 1, lambda minus 4, lambda plus 1, lambda plus 2, minus lambda minus 2. I have done a elementary row transmission. R2 is R2 minus R1, R3 is R3 minus R1. Then I get these things. Then again I have made an elementary row transmission. I wanted to make this 2 0. R3 is R3 minus 2 R1. Thus I got this one. Now expand the determinant by third row. Then I will get minus 2 lambda plus 6 into, in brackets, 3 times lambda minus 1 minus 1 times lambda minus 4. Expand this. Then you will get minus 2 into lambda minus 3 into 2 lambda plus 1. Now delta is equal to 0 will give you lambda is equal to 3 and lambda is equal to minus 1 by 2. Now take the lambda value. Lambda is equal to 3. Lambda square plus lambda, that is 9 plus 3, 12. 12 answer is there against option 2. Therefore, that should be your answer. Now for lambda is equal to 3, we have lambda square plus lambda is equal to 12. If I take lambda is equal to minus 1 by 2, compute lambda square plus lambda, then I will get my answer minus 1 by 4, which is not there in the options. Therefore, my answer is lambda square plus lambda is equal to 12. The answer is option 2. You can stop here. This is how you can save the time. Now, you have not seen delta 1, delta 2, delta 3. Are they each one equal to 0? You not seen. But still you say this one. Right? As far as the exam is concerned, this is okay. But what about, that is the answer for you. Now what about delta 1, delta 2, delta 3? This is only for your convincement, to satisfy yourself, not for examination. For lambda is equal to 3, delta 1, the first row is replaced by the values 5, 7, 9 and the remaining is same in delta. Right? And put the value of lambda is equal to 3 now. 3 minus 4 minus 1, 3, 3 minus 1, 2, 3 minus 4 minus 1, 3 plus 2, 5, minus 3 minus 2 minus 5. Now make a elementary row transmission. That is R2 is R2 minus R1. Then you will get 2, 3 minus 4. And make another elementary row transmission. That is R3 is R3 minus R1. Then you will get 4, 6 minus 8. The determinant is equal to 0. Why? Because second row and the third row are identical. In any determinant, if any two rows are identical, then the value of the determinant is 0. That's how you can convince delta 1 is equal to 0. And similarly for delta 2, delta 3 also you do it, is left to your homework. For lambda is equal to 3, they both become 0. Check. This delta 1 is equal to delta 2 is equal to delta 3 is equal to 0 is only to convince you I have done this. But otherwise you can stop here and you can save some time. Right. Right. So in these 4 questions, the questions are given a system of equations and it says it accepts infinitely many solutions, it accepts no solution and so on and so forth. These are the 2 items that are considered here. But the one thing what is left out is it accepts a unique solution is left. That also you take into and with all these things make a good notes, and that will be helpful for you for the examinations. With these few words, I say, I am sure that you have understood the solutions of these 4 problems. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am going to meet you, all of you, in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.